Opening scene, an image of Earth from space. Narrator: welcome to our exploration of Earth's gravity, the force that keeps us grounded and governs the motion of celestial bodies. Cut to an animation of an apple falling from a tree. Narrator: gravity is the force that pulls objects toward the center of the Earth. It's the reason why apples fall to the ground, and why we stay firmly on our feet. Cut to a diagram showing the Earth and a person standing on its surface. Narrator: on Earth's surface, the acceleration due to gravity is approximately 9 atoms 29.8. Text ms 29 atoms 2. This means that any object will increase its velocity by about 9.8 meters per second every second it falls, assuming there's no air resistance. Cut to an animation of two masses and the gravitational force between them. Narrator: according to Newton's law of universal gravitation, the force of gravity between two masses m1 and m2 m2 separated by a distance r is given by the formula. Display the formula on screen. F equals gm1 m2 r2. F equals g rac m1 m2 r2. F equals g2 m1 m2. Narrator: here, g is the gravitational constant, approximately 670 for 10 11 m12 26 674 times 10 11. Text nc dot text m to text gg 26 670 for 10 11 m12 k12. This formula tells us that the gravitational force is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. Cut to a visualization of Earth with varying distances. Narrator: this means that if you double the distance between two objects, the gravitational force between them becomes 1/4 as strong. If you have the distance, the force becomes 4 times stronger. Cut to a scene showing different objects on a weighing scale. Narrator: an object's weight is the force of gravity acting on it. Weight is calculated by the formula W equals mq equals mq equals mg, where m is the object's mass and g is the acceleration due to gravity. Cut to a map of the Earth showing variations in gravity. Narrator: interestingly, gravity isn't the same everywhere on Earth. It varies slightly with altitude and latitude. Gravity is weaker at higher altitudes and stronger at the poles compared to the equator. Cut to an animation of the Earth, Moon, and a satellite orbiting the Earth. Narrator: gravity is also the force that keeps the Moon in orbit around Earth and governs the motion of satellites. These objects are in a continuous free fall towards Earth, but have enough tangential velocity to keep missing it. Narrator: gravity affects many natural phenomena, such as ocean tides, which are caused by the gravitational pull of the Moon and the Sun. Narrator: understanding Earth's gravity helps us comprehend everything, from the behavior of objects around us to the motion of planets and stars. It's a fundamental force that shapes our universe.